The bright constellation of the Southern Triangle stands out with its perfect geometric shape. During the Age of Discovery, this shining sign gave navigators hope for salvation. Today, the orange Titan Atria shines here, thousands of times surpassing our Sun. This constellation became a true triumph of strict celestial geometry in cosmic chaos.
Today, we're going to conduct a deep analysis of Triangulum Australe, the Southern Triangle. Now, this is far more than just a random collection of stars. It's a historical landmark, really, a symbol of the Age of Discovery. And, at the same time, it's a fascinating natural laboratory for studying the life of stars. So let's begin. You know, in the grand celestial sphere, there are actually two major triangles. The northern one has been known forever, since antiquity. But honestly, it's pretty subtle, made of faint stars. But then there's its southern counterpart. Triangulum Australe is a whole different story. It's brilliant. It's a near-perfect triangle. And it was literally born from the great southern explorations of the Age of Discovery. So here's our roadmap for this exploration. First, we'll properly compare these two celestial triangles. Then we'll look at where on Earth you can actually see it. After that, we'll dive into the astrophysics of the stars themselves, trace the history of its discovery, and finally, we'll explore the incredible symbolism of this celestial shape.
Right, so just to underscore that first point, the Southern Triangle isn't just famous because of its shape. Its location is absolutely prime real estate. It sits in a really dense, rich part of the Milky Way, which makes it a fantastic field for astronomical observation and a major landmark of the southern sky.
Okay, we've established that it's a brilliant sight, but who gets to see it? The visibility of Triangulum Australe isn't random at all. It's all dictated by the precise mathematics of celestial mechanics, and crucially, your latitude here on Earth. So this brings us to the fundamental question for any skywatcher. From where on our planet can we actually look up and see the Southern Triangle? I want you to imagine a line drawn across the globe at 25 degrees north latitude. This line is a hard boundary. If you are standing anywhere north of this line, say in Europe or most of North America, I'm afraid you're out of luck. The constellation will forever be hidden below your horizon thanks to the curvature of the Earth. But if you head south of 20 degrees north, the celestial stage opens up. Suddenly, the entire constellation is visible. This covers a huge part of the globe. We're talking Central and South America, almost all of Africa, India, Southeast Asia, and Australia. It's truly a jewel of the Southern Hemisphere. And if you travel even farther south, past 20 degrees south latitude, something really magical happens. The constellation becomes circumpolar. What does that mean? It means it never sets. It just circles the south celestial pole, night after night. You can think of it like a horse on a cosmic carousel that never, ever stops. All right, we've covered the geography of where to see it. Now, let's turn our attention to the what. What are these points of light, really? We're moving from simple observation to a much deeper physical understanding of the stars themselves. This table gives us the vital statistics of the three stars that form the triangle. You see their brightness, their temperature class, and their distance from us. And these numbers tell a fascinating story. These three stars are not related at all. They're at vastly different distances. We have an old dying orange giant, a young star maybe forming planets, and a hot white one. Their perfect alignment is a complete cosmic coincidence, a beautiful illusion from our specific vantage point in the galaxy. Let's start with the brightest of the three, Alpha Trianguli Australis, or Atria for short. This star is an orange giant. That means it's an evolved star. It's already burned through all the hydrogen in its core and has moved on to fusing heavier elements. It's in the later stages of its life. Now, to give you a sense of Atria's sheer scale, just try to picture this. If our sun were the size of a tennis ball, Atria would be a colossal sphere nearly 9 meters in diameter. And it's blazing with the light of 5,500 suns. It is an absolute titan. Beta Trianguli Australis, the second star, is a totally different beast. It's a younger star, still on the main sequence. But what's really exciting is that it's surrounded by a huge disk of dust. This is a protoplanetary disk, the raw material for making planets. So when we look at Beta Triae, we're getting a precious glimpse of what our own solar system might have looked like billions of years ago. And beyond those three bright stars, the whole area is packed with other deep space treasures. There's NGC 6025, which is a beautiful open cluster of about 30 young stars, all born together. You can spot it with good binoculars. And then there's Henne's 2131, a planetary nebula, the ghostly, glowing remains of a dying star, which looks like a spooky blue ring through a powerful telescope. So we've explored the physics of Triangulum Australe. Now let's pivot to its human story. This constellation wasn't known to the ancient Greeks or Romans. No, its discovery is tied directly to the treacherous sea voyages of the Age of Discovery. Its journey onto our star maps was a gradual process. It started out as a practical tool for sailors, with navigators like Amerigo Vespucci noting it in their logs. Then, the cartographer Petrus Plancius was the first to actually draw it on a celestial globe. And finally, in 1603, the great Johann Bayer gave it official status in his legendary Uranometria star atlas. And this really gets to the heart of its origin. For sailors like Vespucci venturing into the completely unfamiliar southern seas, this asterism wasn't just a curiosity. It was a lifeline. It was a reliable geometric anchor in a sky they had never seen before. For our final section, let's explore the meaning people have attached to the shape. Because once something is named and recognized in the sky, we humans can't help but project our own stories and beliefs onto it. Its perfect geometry has made it a powerful canvas for interpretation. And what's amazing is how different cultures saw totally different things. For the deeply religious European sailors, it was a clear symbol of the Holy Trinity, a sign of God's presence and protection. Later, for Freemasons and Enlightenment thinkers, it became a symbol of reason and cosmic order, the tools of the great architect. And for the Wardaman people of Australia, these stars had their own ancient and profound stories, woven into the laws of nature. So in the end, it's this combination of brilliant stars and almost perfect geometry that made Triangulum Australe the true gold standard of the southern sky. It simply outshines its dim northern cousin in every way. It really is a stunning example of the human mind finding a moment of perfect, clean geometry in the midst of the magnificent, sprawling chaos of the cosmos. And this leads us to one last profound question to think about. When we see this perfect triangle, knowing it's just an illusion created by three unrelated stars at different depths in space, what does that tell us? Is the order we find in the heavens a true reflection of the universe's structure, or is it merely a reflection of our own minds, our innate human tendency to search for patterns and create meaning? That, I think, is a question worth pondering.
Thank you, friends. Strive for understanding and become wiser. See you soon.